Hi, this is Keith Cutter with EMFRemedy.com. Today we're going to be looking at Platinum LED BioMAX 600 EMF Testing. And as you can see from the thumbnail slide here, it was a failure. The BioMAX 600 LED panel failed my EMF testing. Let's get into why. So I purchased the Platinum LED BioMAX 600 for personal use. I'm intrigued by the possibilities of red light therapy and of near infrared therapy, and had always viewed the Platinum LED BioMAX 600 as one of the leading panels. It had been well reviewed by others on YouTube, and yet when I got it home, I found both the magnetic and the electric fields surprisingly high. That's a problem for me because I've been electromagnetically poisoned. I'm a 10-year survivor, but I have my limitations, and although I work as an EMF consultant and help people with in-home EMF testing and designing and building custom EMF homes, I need to manage my personal exposures. So EMF testing is not a game to me. It's not a thing that I take casually. I need to manage my EMF exposures very rigidly. So I've observed testing by other red light enthusiasts on YouTube. And, first I want to say that I think it's excellent that there's general interest in safe levels of EMF for red light therapy. But from what I've seen in other places on YouTube is that both the methods and the equipment seem to be lacking. And I think that that's producing inaccurate test results. So if nothing else here, I want to share the equipment that I've used, the methodology that I've used for the testing, and the results for others who are in the red light therapy space. I have no intention of being a red light panel tester guy. I simply bought this panel for my own personal use, and I tested it for my needs, and I found it to be inadequate. So let's take a look at the meters that I used for the testing. Actually, meter. What you're looking at here are what I would call the professional series of gigahertz solutions meters. The 2 meters on the right-hand side are for RF, or radio frequency, which is the 800-pound gorilla in the room. It gets all the attention from the EMF community. However, there's a lot of high-quality research with regard to low frequency fields. And that's what that meter on the left-hand side, the yellow meter, is all about. And that is the only meter that I needed to use for the testing because there was no RF coming from the BioMAX 600, which is a great thing. So why did I choose the NFA 1000 meter? And by the way, don't y'all go running out and buy one of these unless you're a professional in the field, or like me, you've been damaged by EMF radiation. You probably don't need a meter that's this capable, but it is the right choice for this type of testing because it can do 3-axis electric field potential-free readings. The potential-free part means you don't have to have that little dog leash of a wire hanging out of the meter that goes to a grounded place. You can actually move around freely and pause and step back, and you can take a 3-axis electric field reading with this meter instantly. That's a very unique feature, and it also has the ability to do 3-axis magnetic field readings. Meters like this, the professional series, as I would call it, come with a certificate of factory calibration, and you can get a third-party certificate of calibration as well. I've found that inexpensive all-in-one meters are really not worth it, especially if you're doing critical work. There can be a benefit for somebody who's brand new just to be able to see, wow, there are invisible forces. But in terms of accuracy and measurement, I don't feel professionally that the all-in-one meters are nearly accurate enough for critical work. So I also see what I would call loose data acquisition procedures, unfortunately. So electric and magnetic field are 3D phenomenon, and if you are improperly using a single axis electric field meter and you're trying to do work that needs to be done in 3 axes, you can, by manipulating the meter and taking 3 separate measurements, and then if you're willing to do some calculations, you can calculate for a particular point in space what an electric field value is in 3 axes with a 1-axis meter. But you have to take 3 separate measurements, changing the meter's orientation to the source 3 times, and then you need to take the square root of the sum of the squares of the measured field intensities in the X, Y, and Z axes. You can't just take a single measurement, and I think that's an error that I've seen in all the testing that's being done, or all the testing that I saw on YouTube. So also, you're looking for maximum intensities. You're not just looking for a random spot on the panel. So I used a horizontal stand for consistency and positioned it over a bed. The setup looks like this. That is the panel, and it's suspended on the Platinum LED horizontal stand, and it's suspended over that brightly colored bedspread. There's another angle showing a little bit better, and a third view here of the panel suspended over the bed. And I also used a measured distance from the source. So I see sort of a casual holding of a meter in front of the panel, and to me, that doesn't seem very repeatable. So I want to use a measured distance from the source to allow repeatable measurements all the way from the top of the panel to the bottom of the panel. And I use a wooden box platform underneath the meter during the measurements because it has greater stability during the measurements and there's no movement of the meter while the measurement is being taken. So here's the 3 items I used. In addition to the bed, you've got the panel shown there, the yellow meter, and the meter is sitting on top of an all wooden box. There's another view, and finally, here's a measured distance from the center of the meter. This would be a 6-inch from the panel exposure that I'm showing there. What I saw others doing was measuring at 3 and 6 inches, and I did those 2 and more. We'll talk about that in a little bit. So the next thing I did is I measured the background levels of electric fields and magnetic fields in the testing area because we want to be able to subtract the background level from what we're measuring, right? To be able to get the difference. So here is the NFA 1000. There's a call out on the right. It says EF setting. That means electric field setting. It's pointing to V/M with a green light next to it. That means volts per meter, which tells you that the NFA 1000 is in volts per meter reading mode. And the background electric fields, because this is in a shielded home, is 0.0 volts per meter. This next one is looking at the magnetic field, so the same meter on a different setting. Again, the call out here is magnetic field setting, and the background magnetic field in this house is 0.02 milligauss. So what I would do is I would position the box and the meter at the top of the panel and then slowly work down to the bottom of the panel. And I'm looking for the max value. That's really the proper way to do this kind of work. You're not interested in what the average is or what the minimum value is. You're looking for the maximum value because that's more biologically relevant. What I found was, people were suggesting anything from actual skin contact with the face of the panel. I'm not saying that the manufacturer recommends that because they don't. And they don't recommend 3 or 6 inches either. But I've seen other people online advocating such things. And the magnetic field intensities and the electric field intensities at both are crazy. So at the closer range, you've got magnetic fields of 18 milligauss and almost 6 milligauss. That would be considered in the extreme range. Granted, that is for a sleeping area. I understand that. But as somebody who's been poisoned by EMF, I need to maintain much lower levels. Your mileage may vary. You may have other evaluation criteria. But these levels are much higher than what I'm seeing reported in other places, and I think it's a combination of the equipment they're using and the techniques as well. With regard to the electric field exposures, we're talking about anywhere from about 50 to 63 volts per meter electric field. So the third thing that I looked at was the dirty electricity component, and I've never seen that addressed with EMF panel, red light therapy panel testing. Maybe it has and I've just missed it, but I think obviously when you're having a red light device, you're going to have a switch mode power supply incorporated into the electronics of the device, which is going to create dirty electricity. And the more current draw, which can be significant on these panels, the greater the upset in the dirty electricity or electromagnetic interference. So the initial reading here was 86 millivolts, and the final reading, once I plugged the panel in, was a 327% increase in dirty electricity. That's a 281 millivolt increase. That is a pretty significant increase. So the extreme levels of electric fields and magnetic fields at 3 inches and 6 inches told me that there's no way. That's not going to be something that I could recommend for my clients, who are many of them sensitive themselves, or for my own personal use. So then I began increasing the distance from the face of the panel, and I was able to achieve a 1 milligauss, 1.0 milligauss exposure at a panel distance of 12 inches from the face of the panel. And this is on the borderline between a slight and an extreme, a slight and a severe level of exposure. I'd be willing to do that for a short period of time for a therapeutic benefit. Others might not, but that would have been okay. The problem is that I could not achieve an electric field of less than 14 volts per meter, which is the extreme range, the highest range, at any height above the bed that the horizontal stand would accommodate. It seems to be related entirely to the power cable routing. So I began to get suspicious that Platinum LED had actually shipped the BioMAX 600, at least in my case, with an unshielded power cable. It was very surprising to me. I tried manually restraining the power cable. I was able to get the level down to 10 volts per meter, but that's still the severe range, not acceptable for me. So I did investigate using a shielded power cable. Here's again the photograph of how the power cable comes out. You can see that as it drops down to be plugged into the outlet, because it is not shielded, it has a coupling effect with the human body. And anyway, it creates a large electric field. I found a solution that I could personally use with a shielded cable, but I can't recommend it because of the architecture of the Platinum LED panel, where you're able to daisy chain and plug multiple panels into one another. The shielded cable that I have would not handle that much current and would create a fire danger in that type of a use scenario. So I actually don't have any recommended solution where I could have acceptable levels of magnetic and electric field exposures with the Platinum LED BioMAX 600. So as I said at the outset, my objectives here were to share a test methodology, equipment usage, and also the results for the BioMAX 600. I'll put a link in the description for the NFA 1000 meter if you really feel you have to have one. Again, I don't recommend them for everybody. They're a bit harder to use. There are some drawbacks to the meter. But if you have been damaged like I have, it's probably worth considering. And certainly if you're in the business of EMF assessment, you already know about the NFA 1000. So again, this has been Keith Cutter with EMFRemedy.com. We'll see you next time.